Hey, what's going on, guys? CodeMyGeekins here. In this video we're going to be implementing so-called parse position functions. So before we start, let me explain how exactly the example UCI commands sent from the GUI kind of looks like, in order to give you an idea of what strings in particular are we about to be parsing and making use of them in order to initialize our board state. So before we start, let me mention one quite pretty significant difference between so-called WinBoard protocol and the UCI. So the main difference is UCI doesn't care about the game state. So it just gives you a position that you need to set up on your chessboard, on your inner chessboard representation within your chess engine, and then you just need to run the search and output the best move, and that's it. While in WinBoard, and I'm not sure, but probably the same is in Xboard as well, there you have a protocol that takes care of the entire game, basically. So it's like engine just goes from the very first move and just through all of the games. So that gives some additional opportunities on timing and things like that, but it's not the point. So I just want to emphasize and mention one of the most important things that you need to know about how UCI works. So, like, let's say you don't know any commands, you don't know literally nothing about UCI. So the main idea is you just need to set up the appropriate position within your chess engine and then just call search, and that's it. That's very simple. So UCI is kind of designed to make it easier for programmers, for chess programmers, to actually connect their engines to the GUI. And now we have two commands in order to achieve this sort of a goal. So the first command, actually all the commands that are serving the purpose of initializing the board starts with the word position. So here, and here we have, well, actually, hold on a second, I just forgot to put this word. Yeah. So all these commands serving the purpose of setting up the appropriate board state in the inner representation of the chessboard within your chess engine. So this is the very basic example. So it just sets the initial position, and that's it. And now this one gets a little bit more complicated. So how it looks like from the engine's perspective. So let's say it just calls this position start pause, and you initialize your chessboard to the initial position, and then searching for a move. Let's say your engine finds the move e2 e4, and he makes this as the best move, and then the GUI would send you the command, like if you want to find the best response for black, what GUI will do, it would send you the command position start pause moves and e2 e4 to your engine, and it would initialize its inner board state to start in position, and then it would make move e2 e4 on a chessboard, and then he will search for the best move. And let's say he finds the move e7 e5. He sends this to the GUI like best move e7 e5, and then if you want to find if you want to make a move for whites again, then the GUI would be sending this like command in return. So position start pause, so your engine is initializing the position to the initial position, and then making the moves like e2 e4 and e7 e5, and this is the position to search for the best move now, and so on. And it would go until the entire game kind of ends. So in the deep end game, this position start pause moves, and then literally all the moves in the games, like there might be like hundreds of moves. So I don't know, this might sound a bit weird to somebody, but that's the exact way how UCI works. And the very first two commands we need to implement is actually position start pause and position start pause moves. But the idea is that these moves are available not only in this position start pause, but we can do some moves after initializing to a particular FEN. So we can not only initialize our board state to a given position, but also to a given FEN. And this is quite pretty handy when it comes to debugging. Let's say you want to debug some mating opportunities for your chess engine, then you want to set up the position where it would be a mate, or you're just trying to set up a position for to test your move ordering or things like that. So you can just initialize the current FEN within your chess engine using this position FEN command, and also you can start playing starting from this position. And I'm sorry, I just probably forgot to put this moves. Yeah, so it should be moves like this. Sorry, yeah, so obviously, yeah, this part is the same, so we can go we can make moves after the initial position, and yeah, like this, like here, and we can make moves after we did initialize our FEN. So that's kind of it. And again, like, if we just start playing the game from a particular given FEN, then we just go and play it, and then again this moves would be from this starting FEN position and until the very end of the game. So bearing this in mind, we would now start implementing a function called parse position, serving the purpose of parse either this like command, or this like, or this like, or this like, or this like in particular. So without further ado, let's actually start writing some code. So let's create a function to parse UCI position command like this, and this would be the void function, and just call it parse position, and it would be taking the pointer, character pointer, to the command itself. So just to give you an idea of how in particular the input and output for how the input argument for this command is gonna look like. So it would look like this basically. And just to start providing an idea of how in particular this is about to be working, I will now just I would be calling this function as well. Let me just try to see what we have here. So okay, let me just compile and run the code first. So I just want to say make debug, and if it makes I want to run the BBC binary executable here. Okay, so I don't oh, so we were parsing moves. Yeah, okay, so we don't need this parse move stuff anymore, and I just want to get rid of this. Save. Okay, yeah, so let's say parse position command, and let's say parse position, and let's provide an argument. Let's say just simply position start pause like this. So the very first test here. So if right over in here we just print f our command, and this is, as far as this is the character pointer, it points to the very first letter within this command. So in particular it points here to P. So let me just give you this idea, an idea of how this works. So if you just put the print the character and say the new line, and then just this actually pointer to command like this, it should output P, because it's the very first pointer. Yeah, it's the very first character the pointer is pointing to. But if we just print this like string, and instead of the value of that letter, we just send the memory address or the pointer itself. In this case, we'll have the entire string. So position start pause, and now we need to adjust our pointer so it would start pointing here. So now it points here. but we need to adjust it so it would so it points not here to the very first B but here to S. So to distinguish between either this would be the start pause command or the FEN command, because we might have those two cases. So this might be start pause or FEN. So we need to distinguish between these two cases. So the first thing to consider actually is to shift pointer to the right, where command begins, where position begins, where, let's say, next token begins. So if you just simply say like command plus equals, and now the number we need to shift is calculated the following way. So we shift in 1, 2, 3, 4, 5, 6, 7, 8, 9, and it should start pointing to S. So if we just say like plus 9, it now should print the start pause ignoring the position. Okay, perfect. And another thing we need to do before anything else is actually to initialize the pointer. Let's say initialize the pointer to the current character in the command string. Right? Yeah. So this would be the character pointer, and let's call this current character like this, and it would be equal to command, basically like this. So points to the exact place within the memory where command points now. So if we just print our current character, it should give start pause as well. Okay, perfect. So the next thing to consider, we actually need to distinguish between this start pause and FEN command. So here we want to parse UCI start pause command, and in order to do this I need to use so-called str and compare function, which is the standard C programming language function from the string library intended to match the particular tokens within the string. And the first argument is the command. The second argument is what we are looking for. So in our case, we're looking for a token start pause, and then the number of bytes we need to compare. So in order to get that number, we just need to say 1, 2, 3, 4, 5, 6, 7, 8. So we need to compare 8 bytes. And if this is equal to 0, which means, so if this string compares to string and compare function returns 0, that means that we did actually find our start pause within our command string. So now let's try to print this start pause only in case if we actually able to find it. So now we find it, right? And if I just now put here, well, let's say FEN like this, then we're not gonna be able to, we're not gonna be printing anything because we didn't match that. So what we need to do when we encounter this start pause, we need actually to initialize our chessboard with initial position. So initialize chessboard with start position, and in order to do this we can simply call our parse FEN function and the start position like this. Okay, and else, so here I just say else. So otherwise we want to parse UCI FEN command. So at very least we need to, just to check this, I want to put this print statement here. So at the moment, and actually, yeah, and well, it will now print that we get into that part, into else, and if we just bring it back to start position again, and let's just try to print the board to see the changes actually. So we had this position, and now it should initialize the board to the starting position. So because we did provide this position start pause command. So after so after actually processing this position start pause command, we end up with the chessboard being set up to the initial position, and all the board state variables are initialized respectively. So now let's move on to specifying what exactly we want to do within our parse if we encounter our FEN command. Now to make a little debugging here, so to make sure that FEN is actually available within the FEN string, we can search for the substring. So let's say like make sure FEN command is available within command string, and we can simply say like current, so we're using our current character pointer equals, and I'm using this str standard C programming language function to find the substring within the command string, and we're looking for FEN. And now if it fails, so let's say if no FEN command is available within the command string, so we can say if current character, if this pointer points to a null value, in this case we just want to parse, we just want to initialize our starting position again. And in other cases we actually found our FEN, so found FEN substring, and so else, and in this case the first thing we need to adjust the pointer. So say like, how do I call this? Adjust the pointer. I didn't yet call it, right? So shift, here shift pointer, so I just want to shift pointer to the right, where next token begins, so like this, and I just say current character plus equals, and the FEN itself is 3 characters, so 1, 2, 3, and then there is a space. So let's say in this case, so where the pointer is here, then 1, 2, 3, and 4, and then we go for our FEN. So that means that we need to say plus equals 4. Okay, and in this case we can already initialize board position, initialize chessboard with position from FEN string, and we can simply say like parse FEN and this current character pointer, because it points to the very first character of the entire FEN string. So before actually doing this, I just want to show you this visually. So let's say print F, and I just want to print the FEN, and sorry, like this, new line and current character. save. So let's compile and run to make sure it still compiles and runs. Okay, and now let's take the particular command here. So instead of this position start pause, I would like to make this one, and now it should print the FEN because it shifts the pointer to the right from this to bypass this FEN, so it should print the FEN itself. Okay, and here is the FEN. As far as it prints the FEN, we can already parse it, and even if there would be some moves later on, it doesn't really matter that much because our parse FEN function would only take care of up to here, and it doesn't really care about everything that goes to the right from this string. Okay, so let's actually activate our parse FEN here back. So just to give you an idea, so we were, well, let's start with the starting position here. So let's say start position. Okay, and then so initially we'll have the starting position, and then we're calling this parse position command to mimic our GUI input, and this is the position that we get initialized after that, basically. So getting the position, decide to move, and the board state variables as well. So everything from this FEN string. So the very last thing left here is actually to parse this very last part that regards to moves. So we need to extract those moves, and if any moves are available, we need to make them on a chessboard to alter the position accordingly. So now let's go for this. So here we want to parse moves after position, regardless whether this is the starting position or position taken from our FEN string. Now to do this, I will use this exact method here. So I would be searching for the substring, but this time it would be the moves instead of FEN. And in the case if moves available, so let's say moves available like this, available. Okay, so I can say if current character is not equal to null. So okay, hold on a sec. Okay, this is right because here we match the situation when FEN is not available, and here we make sure that it is available actually, so not equals to null. Okay, just wanted to check that out. So the very first thing, we need to shift the pointer to the right where the next token begins, and in our particular case the next token means the move itself. So if I just, well, let's say just printf this string and the new line and the current character pointer, so it would now, and also don't forget to, well, let's say, well, let's start, it should be working regardless of whether this starts from the start position or FEN. So let's say start pause and moves, and let's say E2, E4, E7, E5. So it now should print moves E2, E4 is 75. Okay. Oh, no, I'm sorry, not the current pointer, current character. Okay. Oh. Okay, yeah, so it prints this moves and so on, but we don't really need moves. We need the entire move string, and we would be actually passing the entire move string to our parse move, because remember that our parse move takes care only of the first 4 or 5 indices of the move string. So there might be many moves, not only one move. So it would only take care of. So here it's index of 4, which is the 5th element, and here yeah. So the first element, the second element, third, and the fourth elements to take care of from this pair is like source square and this pair is the target square. But again, so it might be not like this, but it might be like many moves after the entire move, and regardless of that, our parse move function would only parse this very first move. So it doesn't really matter that if there would be some more moves. So just to give you an idea about this. Okay, so let's get back to our parse position. So the very first thing to do, we need to shift the pointer. So current character would be equal to just adjust it to plus equals, and now 1 2 3 4 5 and plus 1 space, it would be 6. So just like here, so 1 2 3 4 5 and 6. Okay, 6 cells, let's say, plus equals 6, and now it should be printing only the moves. Okay, so only the moves, and we can already initialize our move, but obviously first we need to loop over moves within a move string. So I can say like while pointer to current character. So while it's true, here's our loop, and the very first thing to do within this loop, we actually want to parse next move, and we create the move integer. It would be equal to the return value of the parse move function, and we're passing our current character string. So this is the move string, and this is the character pointing to so say here, then points here, points here, points here, and so on. And the move string is this entire stuff. So it would be like this, and then it would be like this, and so on. So and the value of this move would be either 0 if the move is illegal, or it would be equal to an encoded version of our move. Now, assuming that the GUI doesn't make mistakes, it would be better to say like if no more moves, but obviously this would work if the move is illegal, obviously. So we can say if move is equal to 0, then we just want to break out from this loop, and that's kind of it. And the next thing to consider, we want actually to make move on the chessboard. So I am simply calling the make move function here, and we want to make the move that we've just parsed using this parse move function. So to alter the board position actually, and also we want to specify the all moves flag, because we don't really want to do only captures. Obviously we want to make all the moves available there. Now, assuming that the pointer to the current character is here, so first we need to bring the character to the end of the move, like here, and then we need to skip the space and then go to another move. So in order to do this, so let's specify the commentary. So move current character pointer to the end of current move. So I can simply say like while, and the same condition, pointer to current character, and at the same time this pointer to current character must not be equal to the empty space. Well, without this condition, it would just go along the move string until it reaches the end of the move string. But we want to end this only where only here, basically. So here we can simply say like character, like current character plus plus, and also here we want to, let's say, like go to the next move, and there we just skip this only space here, because when we drop here, that means that we're pointing to the space. So here we just want to say current character plus plus, and that's it. So let me just quickly check this. Okay, so this should be current char like this, and if no more moves, and here we just break out of the loop. So if I did everything correctly, it should now be able to actually print, actually make the moves on a chessboard. So I just want to check this now. So we're let's actually avoid parsing the FEN initially. I don't really want this now. So it should parse the FEN from this command and then print the board. So let's start. Or okay, let's just go. Let's start like this. So now it should print the initial position, but with the move e2, e4 already made on board. Okay, just missed a semicolon somewhere apparently. Okay. Okay, so we got this move e2, e4 being made on our chessboard, and we also have our in peasant square being set to e3, which is generally really good. And now let's also try to test this with let's say response e7, e5, and it should make the move on board perfect, and the in peasant square is set up appropriately. And now let's move the knight like g1 to f3 and so on. So it goes okay, and it would just use some weird move that doesn't exist. It just won't be making that because that move is kind of illegal. Well, okay guys, so this is it regarding the parse position function, and in the next video we'll draft a function to parse the UCI go command. And we're first then, like was already mentioned before, we'll cover just the go depth to make sure that we can search at the fixed depth, and we're not going to be implementing some time settings and moves to go command at this moment particular, but later on obviously we'll make it when it comes to make our chess engine kind of real. So but for the debugging purposes, it's literally enough to have the fixed depth search, just to being able to see how the improvements we would have been making with our search and evaluation would affect the game of the chess engine while it plays versus itself or versus some other opponents. So this is it from my side. Thanks for watching. Until the next time, and take care.